Today we are going to be answering the most difficult question in the world. 1 plus 1. Just kidding. No, we're not. Instead, we are going to be talking about adding and subtracting fractions and some measurement questions as well. This is all review work, but it is important things to know how to do. And so if you're having a bit of a hard time, feel free to listen in and see if you can follow along. Now, the trouble with my fractions over here, guys, is that every single one of the denominators is different. Ugh, that is the worst. When our denominators are different, we can't add them up, and so we have to change that. We have to find a denominator that's going to work for all three of these numbers. So to help us out, I like to think about my multiples. So I'm going to think about the multiples of 3 for a minute. That would be 3, 6, 9, 12, 15, 18, so on and so forth. Multiples of 3, nice and simple, nice and easy. Now we're going to think about our multiples of 5. So let's write those down. I don't have a lot of room. I'm going to write them down over here. So multiples of 5, we have 5, 10, 15, 20, 25, so on and so forth. I could keep writing them out, but I'm going to stop there just so that I don't waste too much of my time. And then I'm going to think of my multiples of 15. Now 15 is pretty hard, but let's see if we can get just a few. So 15 times 1 is 15, 15 times 2 is 30, 15 times 3 is 45. We could do more, but that's a pretty big number, so let's stop there for a minute. So then we look, what number do all three of these have in common? That's our least common multiple. And the first number I see for all of them is 15. So that means my denominator for my fractions has to change to 15 for each of these. So over here I'm going to write 3 15s because each of these is now going to have a denominator 15. Now for this one that's really easy because the denominator is already 15. So all I do is I write my numerator 2 over here. 2 15ths is the same as 2 15ths. These ones are a little bit more tricky though. In order to do that, I'm going to have to think, how do I get from 5 to 15? Or 5 times what gives me 15? Well, if I think 5 times 3 gives me 15. So then I know whatever this top number is, I have to times that by 3 as well. 1 times 3 gives me 3. Very good. Last one here, I'm going to think about the same thing. 3 times what gives me 15? 3 times 5 gives me 15. So the top number has to be multiplied by 5 as well. 1 times 5 is 5. So there we go. We have all three of our fractions now. Now we can't forget about our big numbers as well. The nice thing is, with addition, you don't have to change your big numbers. You can just sort of leave them as is. You can if you want to, but you are going to get bigger numbers. So sometimes it's better to just leave it. There we go. Now I can add my fractions. 5 plus 3 plus 2 gives me 10. So I have 10 15ths. And 3 plus 6 plus 9 gives me 12 18. So I have 18 wholes and 10 15ths. I am almost done, but there's one more thing I need to do. Think about it for a minute, pause the video, see if you can figure it out. Oh yeah, I know what it is. Look at this fraction. We have a 10 and a 15. Those can be reduced. Let's reduce it. So I'm going to divide both of these by 5 because they can both be reduced by 5. 10 divided by 5 gives me 2. 15 divided by 5 gives me 3. That new fraction is 2/3. So the answer to my question is 18 wholes and 2/3. Always reduce if you can reduce. There we go. Now let's think about this one. This is a subtraction question. Sort of gotten into my addition question, but that's okay. We can work with it. So we have 20 and 2 21sts minus 15 and 1/3. I see a few problems that are going to pop up here, but I'm going to focus on the first one first. So I look at my denominators, 21, 3. Oh man, they are not the same. I'm going to have to change those ones up. So over here, I'm going to have to find a new denominator for both of those. So I have 21 and I have 3. I'm going to start writing out my multiples. Now, I actually have 3 over here, so I might just add to this one a little bit. 18, 21, 24, 27, 30, so on and so forth. And my multiples of 21, ooh, this one's a tricky one, but let's just do 2. 21, 42, We could keep going, but those are pretty big numbers. So then we look, what is the first number they both have in common? It's 21. Perfect. I'll just write 21 down for the denominator here. Oh, and this is even better because look, this one's already 21. So all I need to do is write that top number again. 1/3 is a bit trickier though. I have to think, what times 3 gives me 21? 7 times 3 gives me 21. If I times the bottom by 7, I have to times the top by 7. So that gives me 7 21ths. I'm going to write my big numbers as well, my whole numbers. So now I have 20 and 2 21ths minus 15 and 7 21ths. Lovely, the denominators are the same. Let's get going. Oh, wait a minute. Oh, dearie grade 4s, there is another problem. How can we take 7 away from 2? The 2 is smaller than the 7. We can't do that. Well, if this was a regular question, if this was just whole numbers, we'd borrow from the next column. But because it's fractions, well, I don't know. What do we do there? Did you know you could actually borrow from whole numbers in a fraction too? So that's exactly what we're going to do. We're going to look at this huge big number 20 here. I'm going to cross it out and change it to 19. Take one of those whole numbers away. And then that one whole number I'm going to write as a fraction. Now, because my denominator here is 21, I want to write that fraction in 21sts as well. So 19 and 1 whole is equal to 21 21sts, or 21 21ths. Tricky big fraction, but we can work with that. Now that looks really messy, so let's just rewrite everything out here. So now we have 19 as our whole number here, and we have 21 21ths, but we also have these 2 extra 21ths as well. So all together, I have 23 21ths. Very good. And then I'm going to write my bottom number. Nothing to change here. 15 and 7 21ths. Whew. And thank goodness, grade 4s, now this number is bigger than this number. Now I can minus these out. So 23 minus 7, I'm going to have to do some quick math. And that gives us 16 21sts. And 19 minus 15 gives me 4 wholes. I look, I see if anything can reduce, but nope, I don't think it does. So there we go, that's my answer. I'm going to take that answer and write it way over here. 4 and 16 21sts. Well done. That was a lot of work, but we did finally get the answer. Now, to cap this off, grade 4s, I'm just going to look at this measurement problem here. It's been a while since we've done a measurement problem. So we have 5 years plus 42 days equals how many days? So we want our answer in days. That means that we have to change anything that is not in days. Oh, years is not in days. So let's think for a moment. 1 year has how many days in it? Why, it has 365. So if 1 year has 365 days, in order to find how many days there are in 5 years, we're going to have to get a bigger answer. If we want a bigger answer, we are going to have to multiply. And we're going to have to multiply by 5 because there's 5 years. So let's do that for a minute. We're going to do 365 times 5. 5 times 5 gives me 25. 6 times 5 gives me 30, 31, 32. And 3 times 5 gives me 15, 16, 17, 18. Whew, I get 1,825 days. That is a long time, but there we go. That's our answer. 1,825 days. Did anyone catch it? Did anyone see what Miss Ruman didn't do? Ooh, take a minute, see if you can figure it out. Because Miss Raymond's just done something wrong. I'll give you a hint. This is not the full answer. I have to cross that out. Silly Miss Raymond. That's how many days are in 5 years. That should go over here. 1,825 days. In order to find our answer, we have to add another 42 days. So that's what I'm going to do. 1,825 plus 42. 5 plus 2 gives me 7. 2 plus 4 gives me 6.
I have my answer, and that is the number that I should be writing as my final answer.
Do not forget to add them, grade 4s, because it's easy to forget. It's easy to make a mistake, but take your time, be careful, and you will do wonderfully.